Hi everyone and welcome to a new video. Today we're going through an open source project, pretty well funded open source project, trying to understand the code base, trying to understand the general structure that's followed specifically in merge stack open source code bases. And the motivation behind this is that we all open source projects and then we're basically very overwhelmed by looking at the code base. So I just wanted to share the general structure of a merge stack code base. And if this video does well, then we can do it for other sort of code bases and tech stacks as well. I have one request. I feel this video will be slightly slow, and the reason is I want to keep it extremely beginner friendly. So if you feel this was really slow, let me know in the comments. Just basically reply with this was good, this was fast, or this was slow, and then we'll tweak the pace based on that. Let's get right into the video. So the project we're discussing today is cal.com. A few of you have been able to set it up. A few of you have started to contribute to it as well. But a bunch of you are basically overwhelmed looking at it. I was going through the code base today. So my previous contribution, I didn't really go through the code base much. I was able to set it up, but I didn't really have to dive deep into it. Today, I actually dived deeper into the code base, and the structure is very similar to a lot of other merge stack applications. And I've seen almost every good merge stack project. It's divided into some very specific modules and sub-modules, which is what they've done as well. So let's start by understanding what these modules, sub-modules look like for most merge stack open source projects, what each and every module does, and then we will dive deeper into a few modules for cal.com, and I'll show you the code and what they've done, how they've implemented things, and then you can go from there and figure out issues. Cool? Let's get right into it. So most merge stack projects, if this is your root folder, they're basically broken down into two very big folders where you will spend most of your time. The first one is called the apps folder, and the second one is called the packages folder. So if you open the project, if you look at cal.com, you will see a bunch of folders at the root level, but the important ones, or like the ones there where you will spend most of your time, are these two. Let's understand what these have inside them. Packages is a bunch of small packages that either use each other. So one package could use another package, or more specifically, your final apps use packages. Let's understand a few examples of what this is. One very common one is called UI. This contains all of your React components, the basic React components, what your input box looks like, what a button looks like, and the standard styling that you've used in your project using any sort of standard styling library like MUI or Tailwind. So effectively, if you look at the package.json here, you will either see Tailwind or you'll see MUI or some other styling framework, and you'll see a bunch of components. So if you're a front-end developer, if you're a pure front-end developer, this is where you're spending most of your time, writing components and fixing them. There's like almost nil state here. They're like very nicely decoupled components that you've written, and the end team uses it either here in apps or someplace else. But you as the front-end developer, if you're like a pure designer turned front-end developer, this is where you'll spend most of your time. The second one is called either the store or it's called recoil sometimes. Basically has a bunch of your hooks and mutations to manage the state of your application. Now, what is the state of your application? If you look at UI, it basically has a bunch of components, which means a button, an input box, but these could be like highly variable in applications. So for example, if I go to my LinkedIn, you see a bunch of things all around. You see a bunch of posts by people. You see the notification number here is 88. So anything that's specific to me or my view of LinkedIn is the state, which here is 88, a number, 16, another number, a bunch of messages, and my feed. But you and I both see my network, the same icon, the same home button, only the notification number is different. So these numbers, these posts, all these things are called what's called like a state. And you usually store all the logic to create state variables and fetch them in something called store/recoil. If you've heard of libraries like Redux or Zoostand, they basically are frameworks that let you manage state, and recoil is another one that's very popular these days. And that's what's used in cal.com and generally in other sort of popular code bases. That's the one we're learning in my course as well, because most open source code bases I've seen, recoil is the one that's used most popularly. Cool. What does it do? It helps you manage and store state. Moving on to the third one. This could be your config. So it contains variables, global variables like the API's URLs that you might have to hit, a bunch of your own front-end URLs, secrets, things like these. Now the secrets are actually stored at the root level in maybe a root level.env, but them being exposed as variables is done here. So you don't really spend too much time here. You define it once, and then whenever you need a new config variable, you add it here. A bunch of auxiliary tsconfig or ESLint folders, which contain your global linting standards. What is linting, how your code looks, how many tab spaces should it have, and like automatically making your code cleaner by running a command, all the configs for it. And the other one, tsconfig, is basically every sort of package here should have an independent sort of tsconfig. A lot of times the React tsconfig looks very different from a tsconfig that's pure backend, and hence you put all of them in a single folder. Again, something you won't touch very often. Then there's one folder that's fairly common. It's called common. And this contains a bunch of either types. And this contains, so common contains a bunch of your types. Anything that's globally needed by basically all of these guys and a few things inside your apps is stored inside common. And we'll quickly see what that means in cal.com. Then there's something called types, which is basically your global types in TypeScript. A lot of sort of shape of your data and like props that are being sent all around is stored in types. And there's finally DB, or sometimes it's called Prisma, depending on what sort of ORM you're using. But this basically contains a bunch of high-level functions that let you interact with your database, so that you're not writing SQL queries directly in your application. You have a high-level function and you just call it directly inside your apps or inside your UI. Cool. That is more or less a decent chunk of packages. Now, what are these? These are independent packages. Some packages might use another packages. For example, in most cases, UI uses types and UI uses common, because common contains a bunch of your things that are used by other modules, which is like basically bound to be used by almost everyone. And types your UI might need, because these types sort of might be needed here in the UI and in your final app, and hence they need to be put inside a separate module. So the whole goal of keeping things here, like segregating them into modules or packages, is that you have a very nice sort of abstraction of small independent modules that each and every your final app will be using, and a bunch of times packages use each other. Cool. That's one side, packages. What's the other side? Apps. This is your final user-facing application. Basically, the final website of cal.com will probably be in a folder called either web, or sometimes it's called next, if next is the front-end framework that you're using. So effectively, next is never really defined here or never really used here. UI purely has React, unless you're doing navigation here, which I think is like not the best thing in the world. If you want to do navigation, any React or any Next or like front-end framework specific thing should probably be done here at the top. And a bunch of other popular things that happens inside apps are, you have your docs, the final docs that you probably have to publish somewhere in case you're building something that needs user-facing docs. One other very popular end user application is Storybook, which is, it basically contains a bunch of your UIs that the world can see, use. It's your design system for the world to see. And a lot of times you also open source your components. So all these things that are present here, all these things that developers write, or like front-end developers more specifically write, can bunch of times be used by people all around the world. So one very basic example might be Stripe. If Stripe has a design system, a lot of times you need like their button to appear across your website. And so open sourcing your design system, or like specifically the components, is good. And where does Storybook help you? Storybook helps you visualize these, see these, just the components without any app specific logic. What does that mean? Your website will basically contain a bunch of app specific logic, and I'll show this so it'll be a little more clearer. But you have to navigate through a bunch of pages to reach, let's say, a button that you want to see. But in Storybook, you can simply navigate to the button and then see it. Cool. Let's see these in action. I think I've talked a lot here. So what is step 2 after you've done everything and you understand these basic constructs? You need to open the code base. So let's look at the code base. Maybe before I do that, a bunch of other folders that you don't really need to know about and you won't really spend too much time on if you're a pure front-end developer are DevOps, or sometimes called scripts, or ops, which basically contains a bunch of your scripts that actually deploy the thing on the internet. Sometimes contains your infrastructure as code files, basically describing your final deployment as to what your instances look like, describing your infrastructure as code, or specifically like scripts that let you deploy your code from GitHub to the main repo. Also, if you're on GitHub, most probably there'll be a .github folder that contains all of your workflows for testing, linting, and maybe even deploying. Cool. That's the general structure of a merge stack code base at the high level. There are apps, there are packages, there's a .env file, there's a DevOps folder, and then .github. Inside, you have a bunch of modules here. These are the common ones. There are a bunch of small modules that are very application specific. We'll see this very soon in cal.com. And then your final apps are usually Storybook. The final website, if you're building a mobile app, then the mobile app could also be here if it's in React Native, and your docs, which are like public docs you have for people. Cool. Let's go into packages and see if whatever I said is actually true. What all do we see here? We see app store CLI, which seems like a command line interface that lets you, I'm assuming, create your own app or like bootstraps an app for you. I could totally be wrong. I'm not diving into this one. I'll dive into a different one. App store is probably, it contains the front end components for a bunch of like very specific. I think when you're building a dynamic component, basically sounds like they allow other people to create apps. I mean, I know that. For example, Discord, Zoom can integrate directly with cal.com. And when you're trying to do this, you probably want to allow them to bring their frontends inside cal.com, which might be what this does. I don't know. I haven't dived deeper into it. Atoms sounds like a state, although I could be wrong here. And this seems like this has Tailwind, so it seems like it might be a bunch of front-end components. There's like a single component here. No idea what that is. Moving on. Config probably contains your config variables, your theme, what global colors exist. This still seems fairly understandable. Moving on. Core. This sounds like common, which contains a bunch of your things that will be used all around. Event.ts, for example, contains a bunch of functions that will probably use for events. And why is this good or why is this cool? Because this is in your central core folder, which can be used by all the other packages here and also by the main thing, your apps. Cool. And just exposes day.js. Now you might ask, Harkirat, why have they put this inside a folder if all this does is expose another npm library? The answer might be in the future they want to move to a different library and they want to keep the overall high level API of this thing same. Okay, let's make this slightly simpler. If you look at index.js, it exports something called day.js, which is a global variable. They might in the future want to move away from day.js to a different library. And when they do that, they can simply just make their changes here, basically replace this day.js by, I don't know, day.js 2 or some other library. And that way, their high level API that's being used by everyone else remains the same. They internally are able to change the library, even though that won't probably happen here because their folder itself is named day.js. If this was named datetime or like something more generic, then this is a decent way for you to expose external APIs, which it might feel like, oh, why are they creating a new module here? They could have simply just used day.js all across. The reason to do it is just to create another abstraction across the external library. So that if you want to move from one external library to another, you can simply change the high level functions. You don't have to change the high level functions that your library is exposing. The internal functions can be changed, and so that whoever is using it, you don't have to make different function calls anymore. Hope that was clear. Moving on, emails. So this is the one that I want to teach today. So why? Because it's like I sort of need this at work. So I just was very curious as to how they've implemented emails. And this also introduces some new React concepts that might be interesting or intriguing to a few people. Cool. Cal.com sends a lot of emails. Emails don't look ugly. They don't look like simple plain text. And whenever you're sending these emails, you sort of basically, the way to make them look pretty is that you're actually sending HTML and CSS and you're not really sending text, which is why a lot of times when you see promotional emails, they look really pretty. It's basically HTML, CSS, JavaScript under the hood. But again, we all know it's very hard to write HTML, CSS and JavaScript, which is why React was introduced. Sort of makes it easy to write components. But the problem is, React was basically built for websites. It's sort of a framework that's sort of powerful to create websites and be used in a place where you need single page applications. For example, if I am on LinkedIn, without refreshing the page, I can navigate from one place to another. Cool. But you don't really need this in an email. Email simply needs basic HTML, CSS, and JavaScript. But we as developers are very comfortable with writing React. So this library lets you write email components using React, but lets you server-side render them. Now, what is server-side rendering? It's basically a way for you to write code in React, but at least for the first render, not send the complete React bundle, but simply send the thing rendered into HTML, CSS, and JavaScript. So what does it mean? It basically means when you're on a normal website and you ask a server that's running some React code, it basically returns you a very big JavaScript bundle that does a lot of things client side. So on this client, you figure out what to put where, and that's how your, for example, LinkedIn page gets slowly rendered. But when you're on an email screen, you don't really need a bunch of navigation. You don't really need buttons to be clicked to change something directly here on the email, which is why you simply ask the React server for HTML, CSS, and JS for this final looking page. So what this thing returns you is a very nice HTML tag inside which you get body, inside which you get a bunch of styles for the buttons. You also do get this big JavaScript chunk that you're getting here when you're not server-side rendering, but the initial load is really fast. And initially you're getting the HTML that you're getting is what straight up gets rendered versus almost no HTML coming in, JavaScript coming in, figuring out client side what to render. If this was too confusing, read a little about server-side rendering and why it's used and why it's very specifically important in this use case. And there are a bunch of ways to do it. The one that they've used basically is using something called React DOM. So if you look at it, emails, and this is the one that I'm diving deeper into in packages. So like we're going to take 10 minutes here and understand what this does. It exposes a high-level function called render email. So let's look at that. Let's see what it does. Source render email. What does it do? It simply gets a component from the templates folder. So /templates basically contains the templates for each and every email. These are all the emails that you could send. For example, the attendee location change email. If someone changes their location, I'm assuming this is the location of the meeting, you send them an email. Disabled app email, feedback email. So these are like the emails that you could send. And if you look at them, these are React components that sort of render the final email. But as I said, you need to render them server side and simply send HTML, CSS, and JavaScript to the end user. How do they do it? If you look at the high level render email function, it uses a library called React DOM server. It basically does the same thing I explained, which is server side rendering. It renders the thing server side and sends HTML, CSS, and JavaScript, which is why if you look at the high level render email function, this is the only thing that emails this module exports. So this is something important now. Modules are supposed to, these packages that you see are supposed to expose something that other places can use. And this one specifically just exports one function called render email. Where does it export it? If you look at index.ts, this is where it's exported. It also exports a bunch of other things, but the important thing it exports, the thing that it exports as the default is render email. And since the templates here are cal.com specific, this can sort of only be used inside cal.com right now. But in the future, like this is a very nice, they've built sort of a module, which internally might seem like something really small. Most of the logic is basically here of server-side rendering something and sending it back. But it can be very useful and powerful for people like me. For example, I am trying to now build something similar. If this was slightly more generic, if it would allow me to write my own components here, I could simply have used this versus like writing this from scratch. So this is the gist of what emails does. And if you want to test it, they've written something here. If you go to the very bottom, it says you can use an API endpoint to preview the email HTML. There's already one here. Feel free to change it. So next we'll try to understand what that means. Before that, let me quickly take you through the other packages. There's Prisma. This is like the ORM that they use, which is lets you do a bunch of DB calls without writing SQL queries. TRPC is technology you should read about. It's also something they use. It gives you very nice types on both the front end and the back end. Lib, from what I saw, it's sort of like common, contains a bunch of your things that are used by a lot of other libraries. I could be wrong. And then a bunch of other things. UI is the other important one. It contains your actual components. So the thing that I was telling you initially, UI contains, if you're a front-end developer, this is where you'll spend most of your time, and you'll write the button logic, or like write the link icon button, or like if there's a new button that's introduced by the design team, this is where you introduce it and you sort of call it a night. Then the main team, the people who are sort of full stack developers, or like more than front-end, slightly more than front-end, add it to where? To apps. So if you look at the apps folder, there are 4 things here which I've explained. Storybook is the one that will show you components. Let me just take you through that really quickly. If we go to cal.com, so I've cloned the repo locally. I already ran yarn install, so all the dependencies have been installed. So what do you have to do if you want to do the same thing locally? First, clone the repo, then run yarn install. Once you've done it, go to apps/storybook and then run yarn dev. This will actually show you what storybook, like what's its power and like why it's used in the industry, why it's like one of the many end user apps that you create for your end users to, well, in this case, just visualize your components without going too deep inside the application. Versus if they have a very nice storybook component, I can just simply go here and look for the sign up page. For example, they have a buttons page, which has every variation of button that exists for cal.com, both in like light mode and dark mode. So this gives you like the theme for cal.com, for example, in this case. And also you can actually simply just go to the stories. For example, if I go to button.stories.mdx, it'll basically show me what code was written to render such a button. What code was written to render such a button. So if I'm ever using the design system to, let's say, build an application that looks similar to cal.com, and since they've open sourced their components, I can do it. And if I want to know, okay, how do I get this icon exactly? I can simply go to buttons.stories.mdx and find that specific story that's rendering this specific button. So you can see all your components without actually having to navigate the cal.com main application. And you can also see the code for it if you just search for .stories.tsx. So if I go to alert.stories.tsx, for example, or .mdx, then I can see all the alert stories. So basically, whatever you see here is effectively code that's written in some .stories.mdx file. Most probably the front-end developer who's writing components will also write the stories, so that the other person who's the full stack developer, or like the person who's actually maintaining state of the application, can simply look at what they've done and all the variations of the card and can simply integrate it. So their life becomes very easy. And if you're the pure front-end developer, the designer, you can simply create the component, and if you're a really good one, you should also just create the stories, which is as simple as defining alert.stories.mdx or your component name .stories.mdx right next to your component. So if this is your alert.tsx component, you're a front-end developer, you wrote this, you can simply right next to it define another file called alert.stories.mdx, and it will automatically appear here whatever sort of stories you've written, and the other full stack developer can simply use your code. So it's like their life is very easy. Cool. That's stories. And the other one is the main application that I wanted to show, which I guess you guys have already seen. I don't really need to show it, but if you run yarn dx in the root folder, or if you'll actually have to run yarn dx here, because this brings up the database, the other things you need. You can't simply turn on front end and hope everything will work. So if you're going to cd apps / whatever web and running yarn dev and hoping everything would work, it unfortunately won't. Everything works if you run yarn dx in the root folder. It starts the database, it creates a bunch of dummy users for you, it starts the front end, starts the back end, everything cool. And I also had to monkey patch a few things here. I don't know if there's something up with my machine or their code is broken, but there's like the seed.ts file was giving me a bunch of errors, and this is the file that actually seeds the data, basically puts in users and like a bunch of events, and it's like it was giving me some errors, and I just got around it by adding a bunch of try catch statements. So if ever something was breaking, I would just return right there, because I don't really need the data right now. I just wanted to show you guys how to start cal.com. And why I wanted to show you that was because I wanted to show you how email templates can be tested, how you can see an email template right now. The way to do that is if the app is running, which seems like it is. If you might have remembered, if we go here, I think this is still starting, so we'll wait for it. Until then, if you remember emails, packages, email, here, if you look at it at the very bottom, they said there's already one here. So let's go to apps, web, pages, API, and email.ts. Most probably this file uses the email package. So let's go to apps, web API. What was it? Pages API and email.ts. If I go here, this is the sort of important thing to spend some time on. This is what server-side rendering looks like. If you look at the handler here, it's a basic HTTP handler. So this is not even frontend. This is a pure backend call that comes. And when it comes, you look at the very bottom, you set a bunch of headers, you sent the status code for the request. I don't know why this is for the request. It should probably be for the response. The important thing is here, rest.write render email, the function that we exposed where in the cal.com/emails package can be used here, and I simply give it the component I want rendered and the props that I want to send to it. Why is this cool? This is cool because now we have someone making a backend call, but you returning them server-side rendered HTML, which is like sort of the thing that you need to do when you're sending emails. Cool. If I refresh, it still doesn't work, which is not the best thing in the world, because I wanted to show you guys what this looks like in action. Basically, I wanted to go to /email/API/email. This would have ideally, if things are working. Oh, it does show you. Okay, cool. So /API/email shows me this verification email. And why is this cool? Because when I'm sending someone an email, I can simply give them an iframe to this URL, and then this is what they will see in their email. This is how you see pretty emails in your mail whenever someone like sends you promotional emails from, I don't know, Make My Trip or whatever. How do I know this? You can quickly test this in HTML, CSS, and JavaScript. If I write a very basic HTML file, which iframeifies this URL, which in the end will be like something deployed on the internet, you see something like this. Maybe remove hello world, and then maybe give it some height and run. And it suddenly broke again. Anyways, but whatever you see here is what you see here. Whenever this comes back up, you'll see server-side rendered HTML. So what did we learn from all of this? We learned if there's ever a bug in emails, where do you have to go? You go to cal.com, you go to packages. Or if someone has created an issue that says add a new email template, you go here, and this is where you work and create a template. What are these things? Small things here. These are all packages. Where are these used? Either packages use each other, but more importantly, packages are used by the high level apps, and the most important app, the cal.com, whatever you see here, is stored here inside web. This, if I'm not wrong, is a Next.js application, which again uses a bunch of the modules. The core components are defined in UI, not here. So this guy uses that. And whenever you're sort of working with most sort of repositories, even if you go to Backpack, for example, you will see there are packages and there are apps, which in our case maybe is called something else. Everything is in packages for us. Yes, we don't have apps, or like Backpack doesn't have apps, but like app extension is the same equivalent of web here. Ideally, you should have apps. Ideally, Backpack should also have apps as a separate folder, but it's fine. So similar to what's web here is app extension here, and app extension uses a bunch of these. If you look at this, there's like DB, there is ESLint, there is React Common, there is Recoil, which is like the store, there is themes. So again, bunch of small modules, which are in the end what power the app extension, and again in cal.com, what powers the final web application is all of these small packages. Why to decouple it? Because it's easier to debug, easier to write code. You guys get that. Cool. That's all for the video. Was a long one. Let me know if this was fast, this was slow, and then we can increase the pace, dive deeper, make an actual contribution. Or if you like this high level, okay, I understand the code base now, I can take it from here. Let me know that as well. I'll see you guys in the next one. Bye bye.